Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is 103rd lecture of physics, and in today's lecture we are going to explain the process of charging by fraction. In the topic number 25, we will look in detail at the structure of atoms. For now, the following ideas will help you to understand the process of charging by fraction. In this regard, the first one is matter is made up of individual particles called atoms. Each atom has negatively charged electrons orbiting around a small massive nucleus, which consists of positively charged particles called protons and neutral particles called neutrons. The figure shows an atomic model of a beryllium. Now I am talking about this uh, I am talking about this picture. If you are giving a look to it, there is a small nucleus here, and these are the different orbits in which electrons are revolving around the nucleus. So, there are negatively charged electrons orbiting around the positively charged nucleus. The nucleus consists of the protons, which are positively charged particles, and neutrons, which are neutral particles. So, this is an atomic model of beryllium. These are called the orbits. This one is the orbits, and you know from chemistry that in the first orbit there are two electrons, and totally in the second orbit 8 electrons can be adjusted, but because there are 4 electrons in beryllium, so 2 of them will be adjusted in the second orbit. Keep this in mind. One thing more I want to tell you about this figure, that this is a pith ball electroscope. When you want to see that whether charge are there on this pith ball or not, this is having similar charges or unlike charges, these two pith balls will either repel each other or attract each other. So in this regard we can confirm that these both pith balls are having the same charge or unlike charges. So we can see a neutral beryllium atom with 4 electrons and 4 protons and 4 neutrons. That was the first observation. The second one in this regard is the normal state of an atom is one that has equal number of electrons and protons. That is, it is electrically balanced or uncharged. This is the second thing. If an atom is having equal numbers of protons and electrons, then that atoms will be considered as neutral one or uncharged. There is no charge on it. The third important explanation is the electrified state is a state in which the electrical balance is upset. This occurs when some electrons are removed, that is, positively charged state from the orbit or added to the orbit that is negatively charged state, the atom is said to have ionized. Ladies and gentlemen, in simple word, I have written those concepts in yellow. You can see that an object becomes negatively charged when some electrons are placed on it. It will become positively charged if some electrons are taken from it. That was the nutshell of third number explanation. When we are adding or removing a charge, then we say that the atom is now ionized. Either it will have negative or positive charge on it. So when positive and negative charge is coming on an atom, so that is the ionized state of that atom. The fourth explanation is in charging by friction, such as rubbing a glass rod with silk. Some electrons from the surface atom of one object, the glass rod in this case, are transferred to another object, silk in this case. This makes the glass rod positively charged as it is now short of electrons. The silk becomes negatively charged as it gains excess of electrons. Remember that when we are rubbing the glass rod with the silk cloth, then the glass becomes positively charged because it is the donors of electrons, and the silk will become negatively charged because they are the acceptors of electrons. There is a table in which we will discuss when rubbing different things with different materials which will become positively charged and which will become negatively charged. But before that, charge is never made or destroyed in the fraction process. Remember that this is a universal truth, that charge is never made or destroyed in the fraction process. It is transferred from one material to another. That is, it is redistributed. The table shown here summarizes the charges produced on some common material due to the friction process, and that is very important, dear students, because we must have to understand that which one is becoming positively charged and which one is becoming negatively charged. So in the first case, you can see when we rub a glass rod with a silk, then glass will be the donors of electrons, so it will become positive charge, and silk will be the acceptor of negative charge, so it will be negatively charged. Now when we rub ebonite rod with fur, in this case fur will be positively charged and ebonite will be negatively charged, because in this case ebonite rod will have excess of electrons and the number of electrons will be decreased in the fur, so it will have excess of positive charge and less negative charge, so it means that it will be positively charged. Perspex ruler rubbed with woolen duster, perspex will be positive and duster will be negatively charged. Plastic comb rubbed with hair, So here will become positive charge and plastic comb will become negatively charged. When we rub polythene strip with woolen duster, duster in this case will become positive charge and polythene will become negatively charged. Cellulose acetate rub with woolen duster. Acetate will be positively charged and duster will be negatively charged. One thing you have to keep in mind that there is duster here and duster here. In two cases, duster is negatively charged, and in one case, duster is positively charged. So you don't have to think always that duster is either negatively charged or positively charged. You have to see the second material with which that duster is rubbed. So when it is with perspex ruler, then it will be negatively charged. But if it is with polythene strip, it will be positive charge. And similarly with acetate, it will become negatively charged. Keep these things in mind. Now, the next topic is that measurement of electric charge. What is the unit of electric charge? Electric charge, both positive and negative, is measured in coulombs. The coulomb is denoted by capital C, is the SI unit of electric charge. It can be defined from the equation relating electric charge, electric current, and time. I have written these things here in this case that so electric charge in coulomb is equal to current multiplied by the time. Electric charge is in ampere and time is in second, and electric charge is in coulomb. Thus, 1 coulomb is the quantity of electric charge that passes through a given section in a circuit. When a steady current of 1 ampere flows for 1 second. The charge of an electron or proton is 1.6. I am writing it 1.6 into 10 raised to the power minus 19 coulomb. That is the charge of electron or proton. In other words, 6.25 into 10 raised to the power 18 electrons or protons are required to make up 1 coulomb. This shows that the coulomb is a very large quantity, and for most practical purposes we use submultiple of coulombs. The common submultiple used are millicoulombs, and 1 millicoulomb is equal to 10 raised to the power minus 3 coulomb, and 1 microcoulomb is equal to 10 raised to the power minus 6 coulomb. So you have to keep all these things in mind while measuring the electric charge. Remember that electric charge is denoted by Q and electric current is denoted by I and then T. So this is the very important equation in electrostatic Q is equal to IT. From this we can define that if 1 ampere current multiplied by time, 1 ampere current is flowing in 1 second in a cross sectional area of a wire or generally a conductor, then the charge is said to be 1 coulomb. Ladies and gentlemen, that's it for today. Tomorrow we will discuss another very important topic, and that is insulators and conductors. So stick to this channel. Thank you very much for your time. Allah Hafiz.